guys, today we are going to be talking about a very important theory in chemistry known as the kinetic molecular theory. So what is exactly the kinetic molecular theory? Well, this is a theory that gives us a set of assumptions that allow us to use our gas laws, such as Avogadro's law, Boyle's law, the ideal gas law, and many others. Avogadro's law compares volume to moles, Boyle's law compares pressure to volume, and the ideal gas law combines pressure, volume, moles, and temperature into one single equation. Avogadro's law is directly proportional and Boyle's law is inversely proportional. The assumptions of the theory are what allow us to justify these aforementioned laws. So how does the kinetic molecular theory support Boyle's law? Well, the second assumption states that pressure is caused by molecules colliding with the walls of a container. However, when you decrease the volume of the container, the molecules have a greater likelihood of colliding with the walls, justifying Boyle's law. Before we go any further, here are the assumptions of the theory. First, gases consist of small particles that are far apart relative to their size. To put this into context, let me give you an example. If the molecules were the size of marbles, the container would have to be the size of a football field for this assumption to hold true. Second, gases are in constant random motion. The moving particles constantly collide with themselves and the walls of the container. This assumption is what we use to help us justify Boyle's law previously. 3. Collisions between gas particles are elastic collisions. If you don't know what elastic collisions are, there are collisions where the molecules do not lose kinetic energy when they collide. 4. There are no forces of attraction or repulsion between particles. And finally, 5. The average kinetic energy depends on the temperature of the gas. And those are the 5 assumptions of the kinetic molecular theory. When all or most of the assumptions of the kinetic molecular theory hold true, we get a gas called an ideal gas. And you can think of this as the ideal student, a person who gets straight A's, rare but ideal. However, when gases deviate from these assumptions, we get a gas called a real gas. So when does a gas commonly deviate from the kinetic molecular theory and become a real gas? Well, this commonly occurs at high pressures and cold temperatures. So why does it deviate at cold temperatures? Well, if we look back at the 5th assumption, the average kinetic energy depends on the temperature of the gas. So when the temperature decreases, so does the kinetic energy. And when the kinetic energy decreases, molecules move slower, as you can see by this diagram. When the molecules move slower, forces of attraction are able to take place. So now that we've discussed why it occurs at cold temperatures, why at high pressures? Well, we have to look back at the first assumption, which assumes that gas molecules are so small that their volume is negligible. However, at high pressures, we know that volume becomes a factor and is not negligible. Therefore, the kinetic molecular theory does not work. So now, let's quickly summarize the kinetic molecular theory. Firstly, it gives us 5 assumptions that allow us to use and understand the gas laws, such as Boyle's law, Charles' law, and many others. Secondly, when a gas deviates from a kinetic molecular theory, it is called a real gas, and when it doesn't, it's called an ideal gas. Lastly, it deviates most commonly at high pressures and cold temperatures. Thanks for watching, and I hope you learned something about the kinetic molecular theory.